Okay, warm welcome and good morning, everybody. Present here in Krakow, waking up this early in the morning for the final session of the EuroHPC Summit. And it's good to see so many of you wanting to engage with us in a discussion about challenges and the potential of quantum computing on a European scale. So it is readily clear that the European press is somersaulting and not withholding a lot of excitement around the potential of quantum computing for Europe. The technology is seen as the next critical tech, and that can transition from a niche innovation to a powerhouse. It can even transform Europe into the next Silicon Valley of quantum computing. What is also clear is that quantum technologies are seen as key to ensure Europe's sovereignty in deep tech. However, in order to secure the European supply chain, immediate action is seen necessary, specifically reducing funding gaps, ensuring follow-up funding schemes for European SMEs. There's also a talent shortage that can put severe restrictions on growing the European ecosystem. And lastly, as you can see, managing unrealistic expectations and an unrealistic hype that is created around the technology is really key and really necessary for us in order to move forward. So we will use this session to address all of these issues together with you. But before we do, I would like to give the floor to Laure, President of the Quantum Industry Consortium. QUIC is one of EuroHPC's private members. Laure, please, the stage is yours.
So, good morning, everyone. So today is the first day of spring, so it's day 3 of this EuroHPC summit, but that's the first day of spring. That's the yellow color of the day. So that's, yeah, I don't want to talk about quantum winter. We have to change that. So good morning, I'm Laure. I work for SAP as a research director. I'm the president of QUIC, European Association on Quantum Technologies, and also the vice president of BDVA, which is another of these private members of EuroHPC. So first of all, I would like to talk about QUIC, what it is, who are we, what are we doing. So as I said, this is a non-for-profit association of European, of industries and research and RTOs on all quantum technologies. So not only quantum computing, but also sensing, metrology, communication, etc., up to quantum simulation and computing. We look at Europe in the large sense, so EU plus UK, Norway, etc., so relatively similar to your HPC, actually. And the idea is really, so it's a collaborative hub. The idea is really to build this ecosystem, to help each other, members by members, etc., with the target, with the mission to increase, to grow, as company, to grow this ecosystem, of course, to grow the competitiveness of all those quantum technologies. So that's what we try to do. So if we look at the members, close to 60% are SMEs and startups, so that's the biggest portion of our members, up to close to 200 members altogether. Less than 20% are large industry, like SAP, Atos, Airbus, etc. And the rest is RTOs, academia, universities, so relatively classical as an association. And among those industry, by the way, should mention it, we have investors and VCs who are active members. So what do we see? So here what I will explain it to you here is the vision of QUIC, or of all those members collectively, the way we see it. So we did, there is a lot, the good background, a good basis, I would prefer to say. So there is, this European quantum technology flagship who helped to, huge investment from the EU, who helped to, to consolidate, to do those huge research projects and bring it really to innovation, and that still continue. And as part of this flagship, so also covering all technologies, there are also, of course, several related to quantum computers, and now we have established quantum computing centers. EuroHPC is, of course, key as well, and that's the idea to have, since the second regulation, so they introduced the quantum computer, so being part of those HPC center. So it's good for the user, for the researchers to have access to those machines, and also, of course, for whoever is procuring this type of machine, the European companies that can, it's a good benchmark. And it's also good because we can test, we can really use this hybrid architecture, combining HPC and quantum computer, which somehow will be what we need in the future. So why? So you have seen all those press releases, etc. So from the quantum computing point of view, the industry see it as really something that will help. So some people talk about revolution, but that's, we should see it more as a progress. But definitely from the computing side, has been demonstrated that it could help on AI, optimization in general, and AI problem, machine learning problem in particular. And the idea, I mean, I guess most of you know it, it's not to be quicker or more powerful. It's a different way, a different approach on the computing. And this combination of this, again, the classical computing and this quantum computing is really something that could help making progress. As I said, all kind of optimization AI problem, typically, and all domains are concerned, so healthcare, finance, weather forecast, climate modeling, etc., etc. Another asset, I will say, I mean, there is a global competition. We know US and China are really investing massively, but I think there's still space for Europe anyway, and we should see it as an opportunity. We have good assets, a track record in research in all quantum technologies, and not just the last 5 years. I mean, this is really a century history, a good talent pool. There is a lot of scientific publication, so we should not be ashamed. I don't have the figures in my head, but that's a par with US. So all this we should capitalize on. If we look from a fund raising point of view, so here we show we compile some numbers, so just to show you that, okay, if we bring all Europe together, we can be a good comparison with US. With China is more difficult because of those figures are quite opaque. We never know exactly what they count in or not. But also a few examples of really, I mean, last week or last month raising. So you have Alice and Bob, I don't know if Cecil is in the room, raised the Series B, Dutch company on Series A, or Multiverse, so which is more on the software side, doing this AI and quantum computing, who also raised money from the Spanish government. Also achievement, so it's not the only thing to get money, you have to also to do something with it. So also a recent example, but it's not, I mean, the list is much longer, VTT and IQM. So VTT is the Finnish RTO, and IQM is a Finnish startup. They deliver this 50 qubits, so using superconducting technology. You also have the Barcelona Supercomputing Center, I guess some of you are represented here, who introduce a quantum computer. So this shows that it happens everywhere, and this, I mean, this is the path, this is we can grow this ecosystem, we can have this European sovereignty as well. That's other example, maybe the last one. So this project on Q-tests and Q-pilots are also, so that's also from the European Commission, Also interesting because it really helps to validate the product or the solution and accelerate it and of course going up to adoption. So all this exists, it's good assets, achievement as well. However, there are challenges, and that's the topic of the session. And here I will say it's not so different from other technologies, or especially deep tech or anything new. So fragmentation in Europe, similar to other technologies, as I said, this is, we have to make sure that, okay, we have different national initiatives in different countries, not all countries, by the way. So how to make sure they don't double the work, how to make sure they benefit to each other, and also coordinating somehow with the EU efforts. So that's the first step. And not just, I'm not talking here not just about fundings or projects, but also altogether as, you know, how to, the strategy towards this. Intellectual property, it's always, especially in those technologies, it's always difficult to, so we have to make sure we create IP, we develop it, we monetize it, we retain it eventually, and retain in Europe if possible. So that's a challenge, especially for those SMEs who may not have such, I mean, it's really a job by itself. I'm myself not a specialist. And by the way, Quick produced earlier this year a white paper on, okay, what is the landscape in terms of IP, what to do, not to do. So I can refer to you, this is public, you can find it on our website. Standardization, I mean, again, for all technologies, this is the same. And we cannot wait for the machine, the computers to exist before we take care of the standards. We have to take care of it now. And that's also something we do inside Quick. There are a working group on this. And there is this European level. And of course, depending on the technology, it may concern different standardization bodies. So we work, for example, with ScienceAtHome. But one of the challenges, if we look at the ISO aspect, or all those international bodies, we could see, I mean, we have some members that can testify. In the room, JTC3 is a good example. You have 20-something from US, you have a little more from China, and you have 3 from Europe all together. So that's difficult to bring the voice or to have some weight in this standardization discussion. So the target may not be to increase, but at least making sure that whatever we do, we are really facing and we are bringing our voice as European. Funding, I mentioned it before, that's public funding, we cannot be ashamed, but the private fundings, again, similar to other technologies, that's relatively difficult, or we see in US, they systematically got like 10 times easily, I mean, looks easy, so that's a challenge from our point of view. So what do we do with that? So here, this is, and of course the Draghi's report is important as well and points exactly on those aspects. So we have to make sure we grow, we bring these quantum technologies inside Europe, and we really provide, I would say, state-of-the-art technologies and really facilitate this research up to innovation and industry, and really making sure the industry is developing on this. IP, I mentioned it before, making sure, again, we encourage to create, retain, etc., and address the fragmentation. And also one point, little details, but there will be merger and acquisition. That's life of the industry. You know, some are how to make sure, I mean, intra-European mergers and acquisition could be good. If it's coming from outside, how to, I don't want to say prevent it, but at least making sure it doesn't harm the European industry. One example, so that's the favorite example of our executive director, Thierry Botter, who comes from Airbus. this Airbus example where there was a vision from the 70s to build this industry, to really figure out, okay, if we do it in France, in Germany, in UK, this is not enough, or we'll just be in competition, there is no point. So how to overcome this fragmentation, how to coordinate this effort, and really, and eventually dispatch the effort. So having really a strategy, a long-term strategy, a long-term investment as well, making sure the public investment is here, but also the private, and really, you know, not just, okay, you get the money sometimes, but really having a plan to become the global leader worldwide in this. So this is a good example. And I'm not saying we need one quantum leader. We may have several champions. This is a kind of example where we may follow or not, but really the target is this. We have all the assets. There are a lot of challenges. And again, I give you a quick summary. We will discuss during the panel in more detail of those challenges and some that I didn't cover. So, by the way, we published on Tuesday, we published a recommendation by QUIC, so all members of QUIC contribute, I mean, not all, but several members of QUIC contributed to this white paper, which we addressed to the Commission, and we hope, and again, it's public, we hope that could be a help for this future quantum strategy that the Commission is writing, that will be issued next quarter. Up to this Quantum Act. And again, we see the commitment from earlier this year or late last year on the Quantum Pact, where you have all those countries from Europe that signed this pact. They want to commit, they want to invest. So we have all the assets for that. So I just want to thank you on this and just call you for our annual event, Q Expo, mid-May, 14 and 15 of May, first day exhibition, so not just QUIC members, but really exhibition of quantum technologies, and the second day plenary session with members and also international delegation, etc., where we will discuss those aspects. We have also Alain Aspect, the Nobel Prize, we have Prince Constantine, we will have NATO people, etc. So please come and join us. Thank you.
Thank you so much. Thank you so much, Laure. Please have a seat at the panel. Make sure that you have the clicker with you. And I would like to bring Magdalena Stobińska into the discussion, showcasing a little bit how the quantum ecosystem is deployed in Poland. Magdalena.
Thank you, Réne. Good morning, everyone. It's my pleasure to give you a brief overview about QuantEra co-found in quantum technologies. This is a wonderful initiative that was based in European Commission, but the idea was born here in Poland. QuantEra is an alliance of 41 research funding organizations from almost all countries, in particular 31 countries in European Union. These are the European Union member states that can appreciate that funding scheme, and it is coordinated by our Polish National Science Center that is located here in Krakow, actually 1 minute walk from here. This is a scheme that also enables participation of third countries associated with us, such as the United Kingdom, Switzerland, and Turkey. The scientific coordinator of this project is Professor Konrad Banaszek, my colleague from the University of Warsaw, a physicist in quantum technologies, who is running the Center of Quantum Technologies at our university. This funding is oriented to support any quantum technology, so quantum communication, quantum cryptography, quantum sensing, metrology, and quantum computations. This is a call that is co-funded by national foundations. So the money comes from the European Commission, from the Horizon 2020 project, and is supported further by national funding bodies. There were numerous calls within this program so far, starting in 2017. Every 2 years there is another call, and the total budget that was spent within this program amounts currently to 118 million euros. Within this, we were able to fund 101 excellent projects recommended for funding in the whole European Union. If you wish to find more information about this, I encourage you to visit the website www.quantera.eu. It's a very, very informative website where you can find more about these calls, how to apply, the next calls, and so on. I would like to also mention, because behind every great initiative, there are concrete people. So I would like to tell you a little bit about history and people that stand behind QuantEra. The idea came from Konrad Banaszek, who is the scientific coordinator, and the first letter of interest from the quantum researchers were gathered in 2014. 2 years later, QuantEra was launched. The first call happened in 2017, and then it was followed by the first strategic conference and subsequent call in 2019 and then in 2021. In 2022, there was organized a second strategic conference. In 2023, the fourth call was initiated. How the application process looks like, how can we take part in all that? So, as I mentioned, the project scope embraces all possible quantum technologies, but also research, basic research that lies the foundations for these technologies. So all projects that are related to quantum information processing or novel ideas and applications are very welcome as well. The application is composed of 2 steps. So first you prepare a short pre-proposal, and then if accepted, you're invited to submit a full application. The consortia must include at least 3 EU or associated countries, and the project duration is about 36 months. So the evaluation criteria embrace, first of all, the excellence. Scientific excellence is the main thing within QuantEra proposals. So you really have to have a good idea, you have to really convince people that you know what methodology will be used, you know what are the challenges that you will meet, and you know how to go around them. Then, of course, you have to convince everyone that you know how to set up the project, that you will be able to recruit people, that you will be able to divide your work into effective work program, which will be efficient, will be measured by key performance identifiers that will help the Commission to follow your progress. In itself, the project proposal is very similar to the proposals that we submit in Horizon 2020 calls. Once funded, each consortium member submits the administrative forms to their local funding bodies. I participated myself in this call, so I can give you my first-hand impressions, and they are excellent. I participate in the consortium that is coordinated by the University of Vienna, by Professor Philipp Walter. The other consortee is Professor Roberto Osselame from CNR, the Institute of Photonics and Nanotechnologies based in Milan, Italy. And together, we are exploring the possibility of proposing the new quantum computing infrastructure platform that enables us to tackle some classes of problems more efficiently than they are tackled using conventional computing platforms. So, University of Vienna how the work is split between us. The University of Vienna is focused on quantum sources of light, single photon sources, and also on demonstrating, performing, so to say, proof of concept. So they are taking the elements, they are building the setup, and then they are performing experimental proof of concepts. The proof of concepts that underpins the quantum theory that me and my team at the University of Warsaw are establishing. We are the ones who are supposed to propose the problems that are suitable to be implemented in this new platform. That is, select concrete problems in which we will see a benefit from using this new quantum hardware. This task is not very easy. I will get back to it in a second. The CNR, the third consortium, their role is to be, we could say, a supply chain. Once Philip is assembling the setup and we are performing we are saying what kind of task can be demonstrated, somebody has to produce these components that are making up the setup. And this is exactly the team of Roberto who does the job. They have a wonderful technology with which they are producing miniaturized chips, optical chips. They use special technique that was invented and patented by Roberto. And this techniques allows them to produce optical chips in glass that encode very intricate quantum interferometers. These interferometers, they act as processors in our optical computer. Related to our project, you can see on this panel below the structure of our new platform, new quantum computing platform. We are pointing to reservoir neuromorphic quantum computation. What is this? This is a structure that resembles in its build-up structure of neural networks, the neural networks that are the basis of our AI solutions. As we know, AI and the neural networks that implement them are super energy consuming, and often the training takes really a lot of time. So we are receiving very good answers, precise answers. However, they are really costly and you really need to wait a lot of time to get it. So here comes the question, can we do this more efficiently? Can we do this paying less? And we are trying to answer this question. It seems the answer is yes. And the idea is to outsource some of the computations to this quantum hardware. So we are dividing our computations into classical computations, conventional ones, and quantum computations, quantum subroutines that are delegated to this new hardware that we are building. The basis of this hardware is so-called quantum memristor. Memristor is an element, it's a information processing element that we did not invent. It's a one that exists since, I think, 60s, the idea of it, but it's never been implemented. The idea of memristor links two other elements, a resistor and a memory element. So this is where the name comes from. And the role of this memristor in our quantum setup, quantum photonic setup, is to provide a nonlinear interaction. Perhaps you know that photons are happy to interfere with each other in interferometers, but they barely interact, unlike light and matter or matter and matter interactions. For example, I'm sure you know, two electrons are repulsing each other, electron and proton, they are attracting each other. We don't see this kind of interactions between photons. And this is causing a problem to us if we want to produce quantum processors that are competitive in their computing power capacity with the electronic infrastructure. For this reason, there are these ventures like how to bring the nonlinear element into photonic setup, and memory store is one possibility. This kind of architecture may be the basis for the future neuromorphic architectures, in which actually we are able to shorten the training time of our neural network. In this panel on your right side, you see comparison. You see three curves, and they provide us with a comparison between performances of the quantum architecture and classical ones. So the orange color corresponds to the learning curve of usual neural network setup. So you can see that the number of repetitions, once we inject the initial data, the number of repetitions that we have to make in order to allow the network to learn from the initial data and then to foresee correctly the outcome. Here, this is a particular function that we are trying to guess, the value of a particular function that we are trying to guess. It takes really a lot of time. In here, we see that we are getting pretty good convergence to the correct value after 200 repetitions. These repetitions in the language of AI models are called epochs. So we need to repeat the learning process 200 times. And then still, as you can see, the curve is pretty erroneous. It's pretty erratic. It means that the machine is still hesitating. So we are ending up in a situation where we are getting answer for which we are waiting a long time, and this answer is burdened with a lot of uncertainty. Instead, if we will enrich our classical neural network with this quantum subroutine, we are receiving the same answer much faster. We are receiving the answer in about 10 epochs. So you can see that we have actually reduced 20 times the time in which you are receiving the answer, and the uncertainty, that is the error with which it comes, is much smaller. So this is something, one of the examples which hints us that there is something there to look for in these quantum-enhanced, quantum-enriched platforms used for computation. I'm saying quantum-enhanced, quantum-enriched intentionally, because we always have to remember that there is no pure quantum technology. We have to somehow integrate this technology with the existing network, with the existing infrastructure, and this exactly will be done using our classical computers. So every quantum technology, in effect, is a hybrid technology. We need to learn how to merge the two in order to put our finger on quantum benefits. And of course, maybe you follow the press releases. A quantum computer promises us a lot of benefits, but yet it's still an open path, which is super interesting and worth exploring, because something surely is out there. We're not entirely sure what exactly. And that's why a research of that kind that is trying to outline concrete examples, indicate where and what type of advantage we should look for, is very precious. And this all is, of course, possible thanks to schemes like QuantEra. I would like to thank you for your attention. I would like to introduce my group that I am able to support, partly thanks to the QuantEra project. And we are really enjoying this funding scheme, which is flexible, and this allows us to carry out our interesting research. Thank you so much.
Thank you, Magdalena. So I would like to bring Krzysztof Kurowski from the Poznan Supercomputing Center into the discussion. PSNC is actually hosting the EuroQCS Poland ion trap quantum computer.
Good morning, everyone. Thank you, Réne. Thank you for having me in this panel. So let me start maybe with the slide showing the kind of journey and a path, starting from basic research, the already mentioned Quantera program, then at the European level, the quantum flagship, and then some really interesting activities that happen at the European level with respect to the different infrastructures like European quantum sensing and metrology, then quantum communication and the quantum computing at the end. And I would like to give you very briefly the national Polish perspective and present and update you with the current status where we are here in Poland, especially taking the infrastructure perspective as I am representing Poznan Supercomputing and Networking Center. So for the quantum computing, I think it's really important to emphasize the fact that here in Poland, we have been selected as one of 6 hosting entities for quantum, European quantum computers, and we are planning to set up a new trap ion system at PSNC pretty soon. So the deadline is June 2025. And important from the national perspective, I think, is that we build a consortium based on many partners from Poland. And this is the typical thing that we're trying to establish locally pretty strong consortium at the national level and then try to contribute to the European level initiatives. And the quantum computing is a good example. Then I think what is really important to also mention is that it's not about just quantum computing itself, it's about the hybrid integration of classical and quantum technologies. This is what's also already mentioned, and I think there's a really big opportunity. We had a kickoff yesterday of the integration grant project in which 6 hosting entities responsible for quantum systems spread out around Europe will start to collaborate, and I think from the national perspective we can really contribute with many interesting not only ideas but also solution at the hardware and the software level. Then on the other hand, we have been building using the national funding and different infrastructure, national infrastructure projects, also the national level solutions with respect to quantum computing. So we, for instance, established already back in 2023 2 photonic quantum systems at PSNC, so we can also share our experiences with other European partners here in Europe. Now, for the quantum communication, again, we wouldn't be able to contribute to the European level initiatives without a huge effort and many activities that have been taken here in Poland. So we built a national research and educational network. It took us more than 2 decades, and we built like basement to experiment with new advanced cutting-edge technologies, including quantum technologies. And we started, for instance, building the QCAT network, and one of the first links in Europe has been established between Poznan and Warsaw back in 2022, and last year we completed the largest in Europe QCAT network. Again, thanks to all the previous national level activities. So this is another example how kind of synergetic national level activities can build the momentum and build sophisticated infrastructure, which is not only relevant at the national level, but we can also take advantage and contribute to the European level initiatives. And On the top of that, we even started providing and offering additional testing and experimental facilities, and started offering additional added value services for instance, for the reference time and frequency, signal transmission and distribution, atomic clock distribution. So there are another good examples how the national level initiatives, thanks to the national funding, can not only be very useful for Polish quantum ecosystem, but also they can contribute in real concrete scenarios at the European level. Now we're working on preparing the cross-border connectivity, so it's not only Poland but also surrounding countries to be connected through QKD networks. So hopefully we'll see the extension of the network, QKD network, based on the Pioneer NREN, which we accomplished so far. And the last not least example, that's the quantum competences. Very important. We have realized that having good education and also promoting good best practices, and also taking the advantage of many interesting discussions that happen already at the European level. And the European competence framework is a good example how collaboration at the European level, based on prestigious universities and also many experts who contributed to the common scheme of the competence framework, can actually help us to build some recommendations for the national level educational programs. On the other hand, we also have some strategies and qualification frameworks implemented already here in Poland. So it doesn't make sense, in my opinion, to reinvent the wheel, but always double check what's happening at the European level. So going kind of top down and at the same time trying to promote bottom up approach, and hopefully meet in the middle. And this is again good example how we wanted to start with little by little with extending the national qualification framework. This is, by the way, framework dedicated for the secondary technical and trade schools. So we also would like to start at the secondary school level with all the quantum related competences. And now we are trying to concentrate and focus and help not only just one particular university, but also other universities to take advantage of some good recommendations, together with also open educational resources, training courses, workshops, hackathons, to engage more and more potential end users. So to conclude, basically, I think from the national level perspective, we can really and concretely contribute with not only hardware, software, but also talented people to build a synergy at the European level. So thank you.
Thanks a lot, Chris. Now I would like to introduce Jacob Sherson from the European Quantum Readiness Center. So we want to alleviate now from the national perspective more to a European perspective, and also to transition to workforce building and into education. Please, Jacob.
Yes, thank you very much. Maybe I hold a little bit of a special position in the ecosystem because I represent two different fields. I have both the professorship in physics, quantum physics, but also at management. And I'll show you just a little bit of the research that we're doing, sort of that interdisciplinary boundary, and hope to show you that it's interesting, and also that we should have much more when we're charting out the path for the ecosystem in the future, and relying less on maybe consultancy reports when we do that. So basically I'll be talking about three different European initiatives, two on the implementation side, DDQ and QT Indo, on the education, and then also the QCAT's coordination and support action, where we had sort of spun out the European Quantum Readiness Center in order to do this kind of research that I'll be talking a little bit about. So the first implementation initiative is at the educational level. It's a DDQ, so this is where we have 25 partners. We are setting up 16 interconnected master's degree programs, and so we're not trying to create one super education, but just really interconnect all of them, inviting more partners in as it goes, and making an example of this quantum competence framework in practice, where it can be the mediator of collaboration across borders. But more generally, one of the things that we've seen in education is that one of the big challenges is really what are the needs of the workforce, which are dictated by what is the path that the entire ecosystem is going to be following. And we of course have heard about really good signs that are here, and press releases coming out in the last 6 months that are really promising, but there are also signs that there are challenges ahead of us, and one of the things that we ask about in the EQRC is to say, well, the entire ecosystem will follow some sort of Gartner hype curve, and the question that we should be asking ourselves at European level, at national levels, is what can we do today that is going to prepare us in 1 year, 2 years, 5 years, 10 years, that puts this curve, whichever one we are on, a little bit higher, and this will be an increase in competitiveness that we will have. So in the EQRC, we try to support this through community-driven research, every European institution and company, and I'll give some examples of that. So first of all, on the educational side, you can ask, do we have a skills gap? Do we have a lack of power in the training pipeline? And we've been mapping out all of the master's degree programs around the world, and I think one of the good news for the world is that we are ramping up heavily. The other good news is that EU is leading very heavily due to the coordination efforts that we have. So I think there's good news there. You mentioned the competence framework, and the next phase for the competence framework that we have is that we are scraping daily all jobs in the quantum sector and trying to analyze what is actually sort of the end user needs, and then to try to meet those sort of requirements and understand how, on a daily basis, what is the need now and in the future. And we can do various different graphics that shows us where we are today. For instance, it's really interesting to see that the US is hiring more in large companies, whereas EU27 is hiring more in these intermediate-sized companies. Good or bad, that's something for us to decide. What do we do, and how do we make the most out of what we have in the ecosystem today? Another difference to the US is that they are hiring a lot in the bachelor's level. They are also hiring a lot at the PhD level, whereas EU is hiring more at the master's level. Again, how do we map out our individual strengths and then, let's say, differences, and make them into strengths in the ecosystem? Another project that we have running now is that we have worldwide around 62 national and regional strategy documents, and we're pooling all of those together, setting up an AI effort to analyze all of those, and then we can start to say who is prioritizing what and when, and how do we see trends in what is globally being prioritized. And one of the issues that I want to talk about that I think we should talk about in the panel is, I think there's a lack of structured discussions around the differences between the advantages of being a first mover, both on a regional level but also on a company level, and then being a second mover. And this is what I think that objective research can actually bring to the table here, is to establish a language on which we can build our discussions and our decisions. And so if you're a first mover, I'll be a little bit brief here because we can talk more about it in the panel, but you, as a first mover, you can be a hotspot of innovation, you'll be leading the technology, you'll be setting the global standards. But if you are a second mover, you can sort of be adopting the best practices. It's much more cost efficient. You can leverage the existing knowledge and the technologies, and you can also see how the market is emerging, and then you can find the perfect match to your sort of regional competences and the niches that you will then develop business-friendly environments for. And so we're taking these documents, going through sentence by sentence in them, and then trying to sort of match whether they are sentences related to being a first mover or a second mover, and trying to establish this deliberate considerations in the regions, whether, so I think that it's maybe a little bit more random, due to randomness or something like that, whether these statements are there in the documents now, and I think that we could be much, much more deliberate in our choices of where to be a first mover and a second mover. In order to illustrate that, I have just one of the curves here, so temporary data, preliminary data on saying to which degree are you in a region trying to be a first mover in computing? That's the horizontal axis, and in sensing on the vertical axis. And we can see there are some regions that are trying to be first movers on anything, and then there are some that are sort of trying to pick out where can they be the best, use their advantages the best. And Thailand can be one example where they say, well, when the technology matures, we are going to use this technology in agriculture. So that's a very sort of plain example of saying we don't have the strength of being first movers, but we can still reap lots of commercial advantages of that. We also have an initiative where we are interviewing stakeholders across Europe and asking what are the challenges to the ecosystem today, trying to map these out, and again, ask on a company level now what are the differences between being a first mover and a second mover, and trying to compile that together to say what are the kind of key uncertainties that we should be considering when we're making these decisions, technologically, commercially, regulatorily, and standardization-wise, and then try to come up with a list of questions that are research-based and community-based and driven on every company. What should they be asking themselves when they are considering whether and how to ramp up in a quantum effort, and asking themselves, okay, what is the risk tolerance of what is the timeline of development in our industry, and how linked is our core challenge to quantum technology, and again, then deliberately having first movers or second movers. And I think that's one of the things that I see as a big challenge now, is that we are either seeing this sort of domain where everyone believes the press releases and believes that quantum computing is for everyone today. Everyone is ramping up, which if in the, let's say, 2, 3, 4, 5 years it doesn't pan out, then we will have a massive amount of disappointments. Or people listen to the more pessimistic voices, and then they say, well, we should all hold out, and if we all hold out, then we don't see this ecosystem development. So finding that intermediate is about finding the right choices for the right organizations. So then we map out through the interviews, but also through analysis of each of the strategy documents, we map out the ecosystem challenges, and the exact challenges here is not so important to me. It's more the methodology of accumulating all of these so that we can continually have a list that is updated of the ecosystem challenges. Once we have the challenges, then we can map these challenges again back to the strategy documents. We can ask which of the challenges are addressed in which documents, and we have a chatbot coming live very soon where you can chat with whichever of the 62 documents you want and ask exactly these kinds of questions. And I think that will be a really good path forward for making research-based and informed decisions. One other thing that I just want to highlight here in the end is also that I think that there are some maybe communication misunderstandings that are going on around the market readiness and sort of the technology readiness level of quantum technology. And in order to illustrate that, we did a sort of a proof of principle study where we took the 5 most prominent use cases in each of the quantum technology pillars, and we asked what is the technology readiness level of this particular use case. But we also ask what is the market readiness level. And market readiness level is a little bit different because it asks the question whether there is a scalable market already there. When we look at the data, it looks as if it's just linear and it doesn't matter which one we do. But I think it's really interesting to look at the histogram. And when we look at the histogram, we see that there are almost no MRL9s in quantum technology. There's atomic clocks, which may or may not count here, but really, massively, we are lacking a developed market-ready approach, although in all of these technologies we have demonstrations that the proof of principle value is there also in real-world settings. But it makes a big difference whether we are mass-producing this for a market that is already there and is ready to adopt all these studies. So here in the end, I just want to point to the industry education support that is from the union. QT Indo is a project where you can all get free educational support on a number of different 11 and growing number of online and in-person courses. So I encourage you to go to qtindo.eu, look at it. If you thought some of the things that I just said about here were interesting, then we have a course on quantum commercial readiness that I encourage you to contact me for. We are also launching a new course around hands-on generative AI for quantum industry, which we have just spearheaded, and I also encourage you to reach out to me if you are interested with. Thank you very much.
Thanks a lot, Jacob. So we now close this short round of impulse presentations with the European perspective. So Christian, please take it away.
Good morning, everyone. So thank you for being here. And I have the pleasure to close this, this first round of presentation by presenting you the European perspective and opportunities around quantum technologies. My name is Trefzger, and I'm Policy Officer in the Quantum Technology Unit of DG Connect. That is the unit that manages the quantum flagship and other related activities. So my first slide here shows that the quantum ecosystem in the European Union is very rich. So central to this ecosystem, there is of course the Quantum Technologies Flagship, which is a major initiative of the Commission dotated with €1 billion over 10 years. It has been structured around 4 application areas that we all know, so quantum communication, quantum computing, quantum simulation, quantum sensing and metrology, and of course not forgetting about basic science, which is also a very important aspect of quantum technologies. This structure has also influenced many other activities around the European Union and in the world, because we find again this structure about 4 application areas, maybe sometimes more, but we find it quite commonly around the European Union. And what we see around the flagship is that there are many other activities, such as on the bottom left, you see the EuroHPC joint undertaking, also a major initiative with more than €7 billion to deploy supercomputers and quantum computers. On the communication side, we have the EuroQCI, so another big initiative with €2 billion for the terrestrial part and almost 6 for the space part. And on the sensing side of it, on the top right, you see that we are deploying now a new initiative on the space gravimetry that covers the quantum sensing part. And last but not least, we have the CHIPS Act, with which we are developing quantum technology components or quantum chips for the future generation of quantum technologies. So, very rich ecosystem. And as it was mentioned in the presentations before, at the beginning, here on the left-hand side, we had only Quantera and the quantum flagship. So these slides shows the evolution from what we had at the very beginning in 2018, and even before, because Quantera came before the quantum flagship, where we were essentially looking for funding research and move this research from the lab to the market. And actually, we transitioned to the right-hand side into increasing high TRL and essentially to industrialization of quantum technologies. The last proof is the far right-hand side, in which we are doing the European CHIPS Act, in which there is a very strong part in quantum technologies for the production of quantum chips. And in all the funding of quantum technologies, we were, from the European Commission side, guided all the time by the Strategic Research Agenda, which is a document that you see here that has been constructed by the whole community, so bottom-up. And I think in the last version of it, more than 2,000 researchers, engineers, innovators contributed to that. And to testify the change from left to right, so from basic research to industrialization, we upgraded the Strategic Research Agenda to include a Strategic Research and Industry Agenda. So the situation is now we have a research and development program, we have infrastructures like the EuroQCI, EuroQCS, we have the CHIPS Act to produce quantum chips, but what's next? So what is the challenge now for quantum technologies? What we see at the European Commission as a challenge is what the new commission that just started in January 2025 came out with the very first initiative of its mandate, which is the competitiveness compass for the European Union. So this compass is a major initiative that will guide the new commission through the next 5 years or even more of its implementation, and it provides essentially a roadmap for Europe to industrial competitiveness and to economic leadership. So these two things are what we see as the next challenges for deep tech technologies and also, of course, of quantum technologies. And if you see carefully on the right-hand side, in the roadmap that is traced here for the next 2 years, there is a Quantum Act, so a dedicated activity for quantum technologies within the general deep tech sector. So at the Commission, we believe that quantum technology is a very strategic technology, is very important, an important element of the competitiveness of the European Union that may lead to economic prosperity. And thanks to the competitiveness compass for the EU that we have just launched, the first pillar of which is closing the innovation gap by drawing productivity through innovation, and of course quantum technologies is one of the spearheads of the innovation, we intend to reach economic prosperity for the European Union in the coming years. How are we going to do it? Well, first of all, and I think is one of the biggest challenges here for quantum technologies, is facilitate the establishment of startups and make them grow in the European Union. So we are good in the European Union in early technology transfer, in creating early startups, but then once these startups need to grow and need to get big tickets like 100 million euros or 200 million euros, well, they have some difficulties in Europe, and we have to consider this. We have to make it easy for this company to get this money here in Europe and to remain in Europe. And for this, the second point that you see here is that we need to create an efficient venture capital market in the European Union. There is no other way to do this than to incentivize venture capital in the European Union to make these companies grow. And what I would like to say at the end to conclude is that you see that in the first pillar, I have highlighted in yellow the 2 action points that we're going to do to take care about quantum-specific action, which is a quantum strategy for the European Union and a Quantum Act. So in conclusion, we really believe that quantum is one of the key elements of the competitiveness of the European Union that may lead to economic prosperity. Thank you for your attention.
Thanks a lot, Christian. So each and every one of you had a different perspective, a different snippet on the ecosystem building. But there is some commonality across what all you presented, and this is competitiveness and the achievements that we have in the different sections. So if I would ask you, so how would you rank Europe's current position in quantum technology on a global landscape? So what would you answer to such a question? Maybe I start with Laure.
Yeah, not sure how to answer to this. I think, yeah, I mean, again, as I said, we have many assets, but there are those challenges. How to tackle it? It's multifold. I mean, there's plenty of little things, but we need really a strategy. We really need to have this long-term vision and not just hoping that it will pop up by itself or this will. That's the main issue and hopefully this quantum strategy that will come soon from the European Commission. And that's something we have to build together, not waiting that it comes from the top and just we execute. It's a continuous roll-on. So, yeah.
Well, I think that we have to admit that we are lagging behind on many of the metrics, maybe except fundamental research. We are not lagging behind in terms of the potential that the region holds, but that's also why I'm saying is that maybe we are lagging behind in the recognition of what our core strengths are and what we can be building on, and how to implement that into sort of a very manageable strategy. So from the research, I don't want to say my personal opinions, but maybe just relating some of the things that comes out of our research. And one of the things that is emerging is this emphasis on the strength that we have on components and componentization. And maybe we are not building or leading sort of the very, very best of the quantum computers at the moment, but we are really leading in some of the components. And if we, as a very big market, could step into the challenge and then say, for instance, every quantum computer that is built and produced in the European Union should be componentized. And componentization means that it should be very easy to slot out one component and put in another component. Then suddenly there is a market where you don't have to build the whole thing. You actually can be leading in terms of, in Denmark we have Quantum Sparrow, and we build very, very good single photon sources. And if there is a market first in Europe, but also worldwide then, and a trend to say that it should not be proprietary sort of full stack development, then that is one of the ways in which we can go in proactively and create places where we can actually be market leaders.
Please, ladies first.
If I may give my personal perspective, I think we are really, really great at innovation in the sense of creativity, having great ideas. We are a bit less great at implementing them and realizing them. So I think this is where we have to work. And while the first part, we are really at the forefront, in the second part, we are, as my colleague said, we are lagging behind because we don't have maybe a strategy that defines our goals and how do we reach them. We really first should ask ourselves about the strategy. Where do we see Europe in 5, 10, 20 years? If we will define this as our competitors did, I guess this would much facilitate our way towards realizing them.
So I basically agree that we have a great opportunity because at the same time in different places we are working on different innovations, and I think here in Europe, thanks to the regional, national initiatives, at the same time we can actually test different scenarios, but then at some point we really have to push things, especially on the market, and then this is something what is not maybe as efficient as, for instance, the other places around the globe. So I think on the one hand, there are many components. We can do the market research, but then we need better and stronger collaboration to make those components to be fully integrated and deliver at the European, at least, level market.
So just as a follow-up, Chris, because you have first-hand experience on European quantum tech and also US quantum tech, and can you share some thoughts on that?
Well, I mean, we basically always wanted to take advantage of the fact that we believe in open standards and open procedures, and also kind of collaborative atmosphere. And we believe that here in Europe, even if we concentrate locally on some activities, then at some point we can find really interesting partners to collaborate with at the European level, and then based on our experiences, lessons learned, best practices, we can contribute to something which is, even a little bit bigger. So the Euro QCI infrastructure is a good example. Euro QCS is another example. That based on experiences from the local research lab, we can actually build the momentum and then inspire and provide added value to other partners and create something which is much, much bigger at the European level.
Christian, please.
Yeah, I think we're not doing so bad, actually. We have, as you all know, Nobel Prizes at the research level. We are very good also in deploying infrastructures. We are among the best 10 in the supercomputing now. We have 1/4 of the total quantum companies in the world. This is from a study coming from the European Investment Bank. So 1/4, 25% of all the companies in the world are in the European Union. And if you think about the Quantum Industry Consortium, I think is one of the largest association in quantum technologies at the industrial level in the whole world. So we are doing not so bad, but what's happening is that these 25% of the companies are able to attract only 5% of the global funding. So we really have to improve in allowing this company and incentivize this company to grow, in my opinion.
But I think I agree with what you're saying, but I think that what we're lacking is a strategic language, sort of a language for the unique challenge that we have in Europe compared to other regions that are more homogeneous. We have a lot of potential because we have all these different countries and a lot of innovation also and competitiveness, also inside of ourselves. But we are lacking this strategic language of how do we transform all of that diversity into a strategic competitive advantage. And so languages, that's why I'm saying like the componentization. So we need to support also, for instance, let's say control software or something like that. We cannot buy a full stack computer that doesn't have control software that is not interchangeable, because that's where some of our startups are, right? And so we are lacking sort of a language for the very concrete actions that we can be doing, I think, at the moment. I think that's what I'm sort of calling for.
Okay. Christian, you mentioned something very interesting, because you said 25% of the quantum computing companies are based in Europe, but they only attract 5% of the global funding. So are there coherent pathways to overcome this funding fragmentation that we currently have in Europe?
Well, I think this morning we have seen a few successful examples of the European approach. Well, first of all, Airbus was mentioned, so this is a clear European success from the past. In the quantum technology sector, we have heard the presentation about Quantera. I think Quantera was also is a big success of the quantum technology funding approach. So we are able to gather 41 funding agencies in the European Union and associated countries and get together with the same approach to fund quantum technology. So the power of coordination is strong. After all, if you want to build a laser, you need, all the photons to be coherent, to be together. And so I think we should do a very similar thing for allowing companies to grow. So, what the Commission has proposed as a competitiveness compass is aiming exactly at that. Targeting the fragmentation that we have in the funding, in the ability to fund new ventures. And we may have some conservativeness in the European Union. We are less adverse to risk, but here is why the European public support can come in to de-risk investment in quantum technologies and share risk so that we can incentivize more private investment in the sector.
If I may support that voice, I also would like to underline the fact that the importance of sovereign funds. Sovereign funds, not only private venture capitals, would be very helpful in reinforcing this landscape. Why? Because they not only look into the possibility of earning money very quickly based on startups and what they produce, but they also take into account certain policies, our deeper goals that we have actually within our ecosystem. So it again calls for the deeper question of what are we aiming at, where we define ourselves, where do we see ourselves as the leader. Of course, leading technologies will be part of this leadership strategy of Europe, yet it needs to be, in my opinion, clearly defined. Many years ago, we saw technological competition between the Eastern Bloc and Western Bloc, who will conquer the moon first. Now we see this competition within other technologies like AI or quantum. So it's happening yet exactly now in front of our eyes. So I think we really need to understand our purpose and choose the instruments that will support the way to this goal. In my opinion, public involvement, public-private ventures will be the way to achieve them. Thank you.
So I think that another challenge that we have is private funding doesn't just appear. It has to be, you have to earn money from it. And I think one of the things that we are lacking, again, is a dedicated effort to that intermediate time where we're saying, okay, well, maybe quantum computing, if we're very optimistic, are there, right around the corner, but it could also be in the longer term. How do we, let's say in the medium term, how do we formulate a language for the ecosystem challenges that are being met and give that a competitive advantage and also celebrate all of those heroes and give them maybe also a branding advantage of saying that Airbus is first movers, and then we are celebrating that, and we are also giving them something back. At the EQRC, one thing that we are trying to do is to we have something that we call Accords, where all organizations in Europe can self-report what they are doing positively to the ecosystem, and that can be one way of us to sort of celebrating these early victories that we are having that are not tangible in the market yet, but that are really crucial for us in the 10-year horizon.
Chris, because Jacob mentioned something very interesting. Do you believe, as a data center operator, that you can actually have a product in the near future that there is a market for?
Well, I mean, there are some good examples of added value services that we started offering at the beginning for the more experimental scientific communities, but then at some point, there was like a market niche that was actually identified, and we offer some product services also as a national research and educational network operator. So I believe if we continue this journey and little by little add features on the top of existing pretty advanced infrastructures, then we can really create something which is not only useful in the context of scientific communities and end users, but also we can deliver added value services and products for the market. But what I also would like to maybe emphasize that the world is changing now. I mean, it's in like a few weeks we have realized how important it is to collaborate even stronger here in Europe. So I think we really have to start thinking how we can help each other and how we can really create a synergy out of not only discussions but also many joint initiatives, projects, funding schemes, and this is really important because otherwise we wouldn't be able to compete at the global level. So we really have to double check what's happening around us, concentrated not only on the regional or national level, but be more and more open for collaboration around European countries.
Yeah, maybe I would like to add something. I mean, that's also important to include the end users at some point. Not that, not just doing one experiment with, one provider, one user, and we have a test or use case, but really involving them in the whole process and making sure whatever is produced is also serving their needs. And I'm not talking only on the hardware side, but also on the software side. I mean, whoever is on the top, on the right, on your demand, the supply-demand scheme that we have seen before. And that's it's not easy to do, but that's important. And that's something we try to do at QUIC as well. I mean, not just looking at the advance in technologies, but also what for. What's the purpose? And when we say end users, they will produce something also. They will grow on their side, so they need those tools. So that's also something. On the critical component, we need this analysis, this constant analysis, and we see it in the classical computer. I mean, when you have one country far away that is producing the chips, what happens if whatever happens. So that's important to have this analysis to make sure, so not that we have to fill the whole systematically, but be conscious of this and being able to find another solution. In some cases, Europe is the one having this, holding this one or two producers. So that's twofold, but that's also important. So not just filling the gaps systematically, but at least having an overview, a long-term strategy on this.
Fantastic. So I have a final question before we give the floor to the audience. And to all of you, do you think that the European quantum ecosystem is attractive enough for international talents?
I think that, so just to start, I think that the research, in terms of research, we are very attractive. In terms of companies, we have a lot, and we are hiring a lot, and I think that's all good. So, but I think that one of the main gaps we have within the education and the training is really on a high level. So we have lots of enthusiasm, we have lots of people who want to become quantum engineers, but we don't have that many leaders who want to become quantum aware and that we are training them. And I think that's one of the strategic gaps that is really holding us back in our ecosystem development at the moment.
Magdalena, what do you think? Do you think that the European quantum ecosystem is attractive enough for international talents?
I think it is. I think in general Europe is attractive. Personally, I think it's the best place for me to live, and I would like to make it interesting, more attractive for others. I would like to generate here the ecosystem that attracts the talents, the finance, and become a leader in technologies that we are producing. So I think it is. We have very good high schools. We have good financing. We have good infrastructure. I think it's more about thinking how to link the dots and how to organize ourselves in it.
I basically agree that, again, from the infrastructure perspective, what we have built so far and what we are now building jointly, especially under the EuroHPC, is really something unique at the world level. So we have already observed and collected many requests from different places around the globe to double check and get more details what's happening here in Europe, because working again jointly, we can create a synergy and a critical mass and really demonstrate interesting scenarios, added value services and products. So that's, for me, it's clear. Maybe we should be even more market-oriented, more promoting what we have achieved, because this is how the other regions are acting now. So we should believe in Europe, because otherwise, we'll be taken by the others.
Yeah, so I completely agree with this perspective. Europe is brilliant, but too humble and too modest. But with this, I would really like to open the floor to you. If you have any questions, please step forward. Don't be shy.
Maybe until a question comes, I will take the opportunity. I think it's also important, I mean, we can attract, or having even a European coming back to Europe. This is attractive for individuals, but something also, and that's beyond the talent pool, we should really stick to our values as Europeans. This is really, and we've seen this phenomenon in AI. We should not just say, okay, US is ahead and we should just copy-paste. We have a differentiator, we have those values. It maybe look difficult at the beginning. So we talk about fragmentation, but no, this is diversity and this is a richness, which help us in, I don't know, language model, this type of thing. We are the best, actually. Or we always take the example of those GAFAM, etc. But okay, that's B2C. This is the SAP girl talking here, but we are good in all those B2B stuff. So it's maybe not well known on the public. And again, going back to the values, it's important. It's a good basis just for the scientific research, but also for the industry and for the market. And I mentioned earlier, there are several applications on those quantum computing which have something to do with society, with environmental impact, etc. We can make a difference here, and this is important for all of us. Maybe not so many euros, but this is important to do it.
All right, there are some questions in the audience.
So I'm here. So thanks for your presentations. And talking about, I'm Paolo Cremonesi from Politecnico di Milano. And talking about fragmentations of investments and efforts, we are facing two contrasting challenges. From one side, in order to be successful on quantum computing and quantum technologies, we need to focus investments. The Airbus example is a good example. But from the other side, we do not have yet a winning technology on quantum computing, so we need to explore different approaches. So I would like to know your point of view on these contrasting forces. Thanks.
Maybe I will just comment. I think the opportunity that we can at the same time test different quantum technologies, that's the beauty of having the integration efforts at the European level, because at the same time we can double check, if something that is working or it doesn't work. So I think we should be really proud that we have the ability to test at the same time different approaches. But as I mentioned already, we should also be open and encourage the other people, institutions, also industry, to work jointly to create a synergy out of such activities. But the fact that we are testing different technologies here in Europe, that's the big advantage. But how to push this on the market, how to win the global challenges, that's something which is maybe not the best implemented here in Europe, but yeah, we're learning, so we're trying to also promote and see how things happening in other regions.
I think it's an excellent question, and I think that's really related to one of the big challenges that we have going forward on a decision maker level, and that is deciding on a most likely time horizon for quantum computing. And so because if you say and believe that press releases and saying it's right around the corner, then you really need to focus right now, and you need to cut everything away except for the sort of the currently winning horse. And I think that one of the big challenges that we have is really in stakeholder education right now, to say there is no quantum advantage, there is really no indication that it's just around the corner, which means that we should pick that intermediate horizon where we can now diversify and then develop those technologies that are going to be the winning ones. If we had believed 2 years ago in the currently winning horse, no one would have bet on neutral atoms, and we would be in a different place than we are today.
Maybe what I would like to add is that, well, this is my personal opinion, but I don't believe there will be one single winning technologies that will take all. Very likely, there will be coexisting different type of technologies, like, for example, the transistors. In the transistors that we have, there is not one single technology for the transistors, and they are coexisting very well. So I think I agree with you that there is a strength in the European Union on investing in different type of technologies, but we are not investing, at a wide angle. So we are focusing on a few number of technologies, and because we have the belief that very likely a few of them will survive and will be the winners, not only a single one.
And we don't need one at the end. I mean, we may still, because there are different purposes, different type of applications. And don't forget, on the software side, we're not so bad in Europe. Huh? So that's the hardware machine. Well, it's not easy, and that requires physical investment, and but on the software, we have a role to play, definitely. Same as in classical.
So with an eye on the time, if it's all right for you, we can take the discussion to the coffee break. I would really like to use this opportunity to thank all of you for your contribution, for your efforts. Of course, all the presentations, they will be accessible through the event website in the coming days. And I would also like to thank everyone who watched us remotely. And with this, enjoy your coffee break. Thank you very much.